hardly a thing we see or hear or deal with that doesn't get out of adjustment once in a while. And when we know how to make the adjustment correctly, we can keep it all in tune. Whenever you work on the repair or adjustment of a Volkswagen carburetor, you're really involved in a system that has to be kept in tune. Once it's in your hands, it is a system you control. Its many parts and circuits are all designed to operate at maximum efficiency, all engineered to the highest standards in the automotive business. And even though the Volkswagen carburetor is designed to virtually regulate itself, there's a critical adjustment that depends on your skill to make that system perform the way it was intended. We're talking about the idle speed adjustment. So whether you're working with the 28 PICT, the 30 PICT-1 or -2, the 30 PICT-3, or even the 34 PICT-3. It's the idle speed adjustment that brings the Volkswagen engine up to full, smooth efficiency. And that efficiency is based on two factors: the idle RPM and the air-fuel mixture. It's this combination, correct idle RPM and correct mixture, that keeps the engine running efficiently, not too fast or slow, or too rich or lean. And here's where you come in. Let's talk first about idle speed. Turning the idle speed adjusting screw into the right opens the throttle valve and increases the engine speed. Turning it to the left closes the throttle valve, reducing the speed. But what's actually happening to the system as you adjust the idle speed? Let's take a look inside. As the engine runs, the intake strokes of the pistons draw air through the carburetor. The carburetor, which is like a tube, has a throttle valve towards the bottom, which controls the amount of air to the engine. Air rushing through the narrow opening between the slightly opened throttle valve and the carburetor causes a vacuum under the throttle valve. This section of the idle circuit diagram shows the fuel about to be mixed with incoming air. The vacuum, which is below the throttle plate at idle, draws fuel from the float bowl through the main jet to the pilot jet. Air for the pilot jet is drawn into the circuit through a calibrated hole at the top of the carburetor. The fuel and air meet and mix at the pilot jet, and this mixture travels to the volume control screw, where the amount or volume of this mixture is controlled before being allowed to be drawn into the engine. Turning the volume control screw inward closes the passage and reduces the amount of idle fuel-air mixture. And turning the volume control screw out opens the passage and allows a greater volume of idle fuel-air mixture to travel to the engine. So we are concerned with only two carburetor adjustments for correct engine idle: engine RPM and idle fuel-air mixture. Of course, there are many other factors which influence engine operation: condition of the ignition system, ignition timing, compression, and engine temperature. A tachometer must first be attached to the engine before correct adjustment can be made. Turn the idle adjusting screw in or out until the idle RPM is correct according to the tachometer. Then adjust the volume control screw, turning it in slowly until the engine speed starts to drop. Then turn it out between 1/4 and 1/2 turn until the engine runs smoothly. Now repeat the idle speed adjustment, watching the tachometer, and if necessary, readjust the volume control screw. We've been talking generally about the 28 PICT and the 30 PICT carburetors. Although they are different models, they do have the same adjusting sequence. First, the idle RPM, then the volume control screw, and finally, check the idle RPM again. But on cars equipped with emission control devices, some changes were made that require different adjustment techniques. The 30 PICT-2 carburetor, which was installed on 1968 Types 1 and 2 vehicles, is the first of the emission control carburetors.